All right, today we're doing lesson 3.7 on function notation. So go ahead and write your learning goal at the top. I can use function notation to solve problems involving linear relationships. So this part is what we're doing today. So you can just write that down in your notes. The next part is for the second lesson, comparing a linear function to the parent function, f of x equals x. So just write down the part that I underlined. So use function notation to solve problems. And we're also going to be doing some graphing today, graphing real world type of questions. And practice writing domain and range for different real world problems. Okay, so the next part of the note says new names for functions. Now you should already be familiar with some of this, but the old way is to write y equals. The new way, well, we'll still be writing y equals sometimes, but function notation is f of x equals. F of x is the same thing as y. It's the output. It just is a way to specify what the input variable is, because when you get to more complicated type of functions, there can be different variables like x and y and z. So it's a way to say what your input variable is. Everything works the same with y equals notation. So the domain is the values of x for which the function is defined, and the range is the values of f of x. So range is f of x and domain is x. Do you have a pencil? Abel, do you have a pencil? There's one in the back in the cup. This is things you should do in your first couple months. 15 minutes. Graph the same way, so table of values, intercepts, or slope-intercept form. It's pronounced f of x. It does not mean like the f times the x, so you're not multiplying what the x is by the f. It's just a way to write the y value. It means that the output of the function, it means the output when x is the input. Also, it means the value of f at x. So the value of the y at a certain x value. And so think about like a coordinate plane. A coordinate, for example, like 2, 5. When x is 2, the value is up at 5. So that's all that's saying. And it indicates that x is the input. X is input variable. And we can use other letters such as g. So you can have g of x, you can have m of x, you can have p of x, and you can have different input variables too. Like you can have d of t. What do you think d of t means? I mean, like what do you think the d and the t mean? Distance and time. Yeah, distance is a function of time. Time is always your independent variable because nothing changes time. And then let's do some practice. So our first example is f of x equals 3x plus 5. So this means the same as y equals 3x plus 5. And x is the domain or the input. And we'll use this example down here. So f of 3 means that you're evaluating f of x when x equals 3. See how we replace the x with the 3? That means we're going to plug 3 into x into the regular equation. So f of 3 means, actually, I guess we're using this equation here, 3x minus 15. So f of 3 means 3 times 3 minus 15. And so let's simplify that. 9 minus 15 is negative 6. So that means f of 3 equals -6. As a coordinate, this means that the x, when the x is 3, the y is -6. So you should be writing this down. So that's what it would look like as a coordinate. Or another way that you might see it is 3, comma, f of 3, where f of 3 just means -6, because that was the function's y value when the x is 3. Okay, let's try some other examples. So if f of x equals -7x, let's find f of 7. So what would f of 7 be? Well, that means we plug in 7 for the x. So now it's -7 times 7. Yeah, -49. For part B, you're finding g of -2. So g of -2 equals 12 times -2 plus 1. 12 times -2 is -24. -24 plus 1 is -23. So -23 is the answer. For part H, what is h of 0? What's h of 0? Abel? Yes, because that just means x is 0, that goes away, -2. So that'd be like the coordinate -2, 0, like your x-intercept. Oh, sorry, your y-intercept. Well, no, I'm sorry. I wrote that the wrong way, didn't I? Because the x is 0 and the y is -2. So that is the y-intercept. For part D, P of 2 is -3/2 times 2 plus 5. What's -3/2 times 2? Lucas?
6/4.
I mean, look at the 2's. You see that this 2 here cancels with this 2 here. So the 2's cancel out. So it's -3. I mean, you weren't wrong, but you weren't catching the trick I was trying to get you to see. And then that would be equal to 2. So when the x is 2 here, the output is also 2. All right. Now the next problems, we are going to work backwards. So they're asking a backwards question. They give you that f of x equals 2x minus 10. Find the value of x. So it says to find x so that f of x equals 6. So now we are going to replace not the x with 6, but the f of x with 6. So we're going to replace the whole thing here with a 6. So 6 equals 2x minus 10. So we're not plugging 6 into x. We're finding x when the y is 6. It looks like an x. When the y is 6. And then you would solve it. So you're going to add the 10 over. And that's 16 equals 2x. Divide by 2. Take, yes, 8. And so this means when x is 8, the y is 6. Okay, number 2. It says find the value of x so that f of x equals 1. So we're going to replace the f of x with 1 equals -2x plus 4 and solve it. So subtract the 4 over to get -3. Divide by -2 and you get positive 3/2 equals x because the negatives would cancel out. And the next page is the word problems. Yes, you will need some space for the graphs. Okay, question 1. The average price of a movie ticket in the U.S. from 1980 to 2000 can be modeled by this function. So it's the price of a movie ticket. So it says y equals 0.1x plus 2.75. So let's look at this equation first. What does the 0.1 represent? This doesn't ask this in the question. I'm just asking it so we can understand it. What does the 0.1 represent? I saw some hands and now I don't see hands. Lucas?
Isn't that like how tickets are like time?
X is the number of years since 1980, but that's not what the 0.1 represents. Tate? It has something to do with the price of the movie tickets, but it's not the price of the movie tickets. Yes, how much the price is increasing every year, each year, because it's the slope. So the price increase per year. So it's increasing by an average of 10 cents per year. It's not exact, it's just like a line of best fit, you know. And then what does the 2.75 represent? What does that represent? Oliver? When? Jude? In the first year, which is 1980. So the price in 1980. And so every year it's increasing by 10 cents on average. Okay, so now we understand the equation. Let's answer the question. So graph the function and identify the domain and range. So when we identify the domain and range, or when we graph a function, it's easiest to find the domain and range first and then use that to graph the function. So our domain are the values of x in the problem, and the value and x is the number of years since 1980. So when it's 1980, how many years has it been since 1980? 0. So our smallest value is 0. No, when it's 1980, how many years has it been since 1980? 0. So 1980 represents the year 0. 2000 represents the year 20. So our domain is 0 less than or equal to x less than or equal to 20. Okay? For the range represents the price of the movie ticket in 1980 to the price of the movie ticket in 2000. So we already know that the price of the movie ticket in 1980 is 2.75, right? So 2.75 less than or equal to f of x less than or equal to, now how do we find the price of the movie ticket 20 years later? We get out our calculator and we plug 20 in for x. Yes, so this is f of 20. We need to calculate what f of 20 is. So get out your calculators. 0.1. I mean, actually, you might not need your calculator. Hang on, let's just do it with this without a calculator. 0.1 times 20 is 2. And 2 plus 2.75 is 4.75. So you actually didn't need a calculator for that. What the heck? What is this? 4.75. Okay, now that we have our domain and range, we are going to flip over to the graph part. And we're going to graph it. So, and in order to graph it, I need to extend the page. We need to figure out an appropriate x and y axis. So our x-axis needs to go from 0 to 20. So how about we go in increments of 2 years so that we can go 0 to 10. So 10 tick marks on the x-axis. Is that okay with you? Okay, so we're only going to work in the first quadrant. So take your straight edge. I will pass out a ruler in a second. And you're going to make an x and y axis. I would just stick in the top corners. Like mine is going to be about, yours will be about this big, okay? And then also extend it up to be the first quadrant. And if you want, you can start labeling. Your x-axis is time in years, and your y-axis is price in dollars. Okay. So let's set up our x-axis if you haven't already. So it's going to be time in years since 1980, and then the y, and then it's going in increments of 2 years. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, and then your y-axis is price in dollars. So our smallest value is 2.75 and the biggest value is 4.75. So we can start at 0 and then go up to what on the y-axis? Lucas says $10. We could go up to $10. We could, but do we need to go that far? How about 5? You always want to go like a little bit further than what you need, but not too much further. So how about 5? So if we go up by 5 for $5, instead of, so we could space it out a little bit, let's go up in increments of 50 cents. Because if that's 50 cents, then we would need 10 tick marks on the y-axis. So we're going to go in increments of 50 cents. So 0.5, 1, 1.5, $2, 2.5, $3, 4.5, $3.5, $4, 4.5, and $5. And then you plot your first point and your last point. So the first point is from the beginning of the domain, which is 0 to 0.75. So right there, in between the 2.5 and the 3. And your last point is at 20 and 4.75, so right there. And then you're going to take your straight edge and connect it with a line segment. You're not going to include arrows or go past these points because the pattern, the function doesn't go past it. It could possibly change. All right, so we're done with problem 1. Actually, we're not done with problem 1 because there are more questions. Part B says to find the value of x so that f of x equals 4.55. So it says, I'm just going to write the work here, but you can write it on the previous page. So f of x equals 4.55. So this means that we're going to find the year when the price of the movie ticket was $4.55. So we're going to set the equation equal to 455 and solve for x. So let's subtract the 275 over. 4.55 minus 2.75 is 1.8. Is that right? And if you divide by the 0.1, you get how many years? Jude? Yes, 18, which is the year 1998. Far before you were all born. You were just a figment in time. Yes, I was 5 or 6 at the time.
Or 6 or 7.
No, I was not 6 or 7. I was 5 or 6. I was born in 1992. Okay. Number 2. No, I wasn't. I was born at the end of 1992. All right. Next question. The number in thousands of DVD players sold in the U.S. from 1998 to 2003 can be modeled by this function, where x is the number of years since 1998. Graph the function, identify its domain and range. Alrighty, so let's take our domain. We're going to find our domain first. Remember how we wrote the domain for the previous question. So 1998 represents the year 0, and that means 2003 is the year what? Sabrina? Yes. That means our domain will be 0 less than or equal to x less than or equal to 5. And then the range. What is the value of f of x when y equals 0, or when x equals 0? In other words, how many thousands of DVD players were sold in 1998?
Where do you get 5 from?
2003 is 5 years after 1998. Yeah.
I'm a jack.
Okay. How many DVDs were sold in 1998? Theo? Yes, you got that from looking at the y-intercept, right? Okay, stop playing with the rulers. Pay attention. So 330 less than or equal to f of x less than or equal to what? How do you find the number of DVD players sold in 2003? You plug in 5 for x. Yes. So let's find f of 5. Are we paying attention? Okay, so find f of 5. Write that on your paper. So plug in 5 for x. Matthew, plug it into your calculator. You got a calculator right there. So you got to pay attention. Pay attention. You guys, this is your chance to be YouTube famous, and you are butchering it.
What? I'm in here too.
Theo, what'd you get? Shh. Said 21, wait, 21,000 what? 580. I agree with that, okay? And so now we have to graph it. So for your x-axis, we need to go from 0 to 5. Let's set up your graph. Mine is about the same size, so it's about like 10 by 10-ish. Okay, so there's that, and then make your y-axis. So this is time in years since what on earth? Oh my gosh. Pressing buttons. Since 1998. And then the y-axis is number of DVD. Thank you. DVD players sold in 1,000. So it's not just there weren't just 330 DVD players sold. There were 330,000 DVD players sold. Okay. So if our biggest value is 21,580, we can round up to 22,000. So we'll need to go all the way up to 22,000 on the y-axis. So what should our increments be? Increments of 2,000? Yeah, I think that's a good idea because then we would need 11 tick marks. That's reasonable for the amount of space that we have. So let's go in 2,000s. No. So this is 6,000. I'm gonna write 6K for abbreviating. 8,000, 10,000, 12,000, 14,000, 16,000, 18,000, 20,000, and 22,000. And then how about, since we only need 5 years, let's skip every other year as a tick mark, or sorry, every other tick mark is a year. So I'm going to skip one and write 1, skip another, 2 years, 3 years, 4 years, and 5 years. So I guess the goal when you're graphing is to space out your graph a little bit so that it's easier to see. You don't want everything all squished into one corner of the graph, right? Okay, so our first point is 330 at 330, which is basically very close to 0 because the first y value is 2,000 here. So your first point will be way down here. and then the second point will be at 5. The ending point will be at 5, and then between 20,000 and 22,000. So 5 years later, the graph is up here. And then you will take your 2 points and connect them with a line segment.
What?
Okay, and then when we go back to the other question, it says find the value of x so that f of x equals 13,080. Explain what it means. So I'm going to give you a minute to try that on your own and write a sentence. So you would say, you're finding the year. So you'd say like in blank, like in 2025, there were how many thousand DVD players sold? So I'm going to give you a minute to try it. If you have an answer, then raise your hand and I'll check it. You have to say what the year is. So pick up your pencil. You don't have your calculator out by now. You might want to get it out.
Mine's dead.
It's unfortunate.
It's very unfortunate.
And we usually don't make it to that last example, so I don't know. I might try it. I might squeeze it in.
Well, I don't know what's the season.
Yeah, I
Figure
got
it
a
out.
cow.
So you're answering part B. Okay. Yes, find the value of x so that f of x is no, you're not answering question 3. You're doing part B on number 2.
Find the value of x and f
Are you doing? You did part B. You answered number 2. So say in that year there were this many thousand. Yep, so write a sentence to explain what it means. So in blank, there were blank CDs sold for DVD players. Okay. So the idea here is that we're going to set our equation equal to 13,000. Oh my gosh. 13,080 equals 4250x plus 330. Subtract the 330 over and get 12,750 equals 4250x. And if you divide by 4250, I mean, you don't even need a calculator because 12 and 4 is 3, 750 and 250 is 3, so it's 3. So x equals 3. So what year corresponds with x equals 3? Okay. Yeah, so on your paper, make sure you write this out. In 2001, there were 13,000. Actually, if there were 13,000, there are 13,000 thousand. That actually means 13 million. Because there's an extra thousand at the end. DVD players sold. And I lived during that time, and I can confirm that yes, DVD players were experiencing quite the boom in the early 2000s. Nice. All right. That is the end of this lesson. We're going to skip question 3. I usually don't get to question 3, that's okay.